Welcome to the Deep Dive Books channel, where we hope you find something valuable every day.
Seizing the popularity of DeepSeek, let's talk about training methods for large language models, LLM, which may also inspire our own learning. AI imitates humans, and humans can reflect on themselves by comparing with AI. Currently, AI researchers have thoroughly understood the concept of thinking and conducted numerous experiments and quantitative analyses to find the most efficient way of thinking. How do the AI models you use master intelligence? Training a large language model can be divided into 3 stages: pre-training, supervised fine-tuning, SFT, and reinforcement learning, RL. Pre-training involves using massive text corpora to let the model read extensively. All kinds of books, articles, audio, videos. Anything that can be accessed should be included, requiring a huge amount of clean, high-quality data. The task of pre-training is to teach the model to predict the next word. A model after pre-training is like a well-read child who has accumulated vast amounts of knowledge, but hasn't gone to college yet. When you mention something, the model has some vague impression, and it can even guess what word you're about to say next. However, it lacks the ability to take action, because it hasn't learned how to produce output properly, nor does it know how humans expect it to act. The purpose of SFT is to teach the model to speak human language. Trainers provide the model with numerous examples, showing how it should respond to different instructions. During this stage, the model learns vast amounts of data in the form of instructions plus expected responses. For example, if someone asks you to translate a sentence, how should you respond? If someone gives you a math problem, how should you solve it and write out the steps? If asked to analyze something, how should you list points 1, 2, and 3? The SFT phase is like a child finally attending university, where they learn systematically. Not knowledge, but behavioral norms. Teachers guide them on writing formats, answering procedures, logical thinking routines, etc. The child becomes more and more professional. But simply knowing the routines isn't enough. They must be executed well. This brings us to the 3rd stage, RL. If you ask the model to write an essay, it could either give a few hasty sentences, write beautifully but without logic, or write logically but be dull. How can the model know what constitutes a good article? The answer is learning by doing and receiving feedback. A year ago, people would call this stage RLHF, reinforcement learning from human feedback, to emphasize aligning with humans, but now the term has been simplified to RL. The usual approach is to let the model generate multiple different answers, and then have humans, or other data, evaluate the quality of these answers. Good answers get a reward, while poor ones get a penalty. Through this reinforcement, the model gradually learns what is good. Aligning the model's output with human values also occurs during the RL phase, such as ensuring politeness and adherence to moral norms. The core idea is that the model should output in accordance with human preferences. If you overhear a conversation between 2 AI researchers, you'll often hear the term RL. Whether a model is advanced or not mainly depends on reinforcement learning. In simple terms, pre-training accumulates knowledge, SFT teaches methodology, and RL determines output quality. All large language models go through these 3 stages of training. Models like OpenAI's O1 and DeepSeek's R1 follow this training process as well. What makes reasoning models special is the enhancement of the chain of thought, COT. Traditional large models also have a chain of thought. You give them a problem, and they can step-by-step think through it based on intuition, producing complex results. But traditional models have only one chain of thought, directly outputting an answer. Whether it's good or bad is just the result. Reasoning models, on the other hand, possess the ability for slow thinking. They consider multiple chains of thought, choose the optimal solution, and then formally output it. This is similar to playing Go. Expert players don't just rely on their immediate intuition but consider several choices, calculate the variations, and think carefully before making a move. The pre-training of reasoning models is the same as traditional models, but the thinking chain is strengthened during the SFT and RL stages. During the SFT stage, researchers deliberately show the model many examples with complete reasoning processes, detailed steps of solving math problems, analytical reasoning processes, and hierarchical writing styles of long articles, among others. This helps the model learn the chain of thought. During the RL stage, the model learns to evaluate different chains of thought and optimize the reasoning steps. The core competitiveness of models like O1 and R1 lies in the chain of thought. As we enter 2025, several papers on reasoning model thinking chains have already been published, and I've gathered 3 insights that I'd like to share. The first insight is that, the longer the chain of thought, the more likely it is to solve complex tasks successfully. A long chain of thought means going further in one direction, thinking deeply. Researchers have found that, if the model's chain of thought is long enough, some abilities will emerge spontaneously, such as backtracking when encountering logical contradictions, or checking for errors in intermediate steps. These abilities will emerge naturally. In simple terms, to have high intelligence, you must be a deeper seeker. A paper from IN.AI, Tsinghua University, and Carnegie Mellon University shared a method for training models to generate long chains of thought. Although seeing more examples of others thinking in the SFT stage is helpful, the key is RL. You must encourage the model to think deeply. As we mentioned in the A Brief History of Intelligence section, high-level reinforcement learning should not just reward the final result, but also reward the process. You need to give some rewards for the intermediate steps of the model's thinking, even if the final result is wrong, as long as the steps were worthwhile. This is not easy. You need to find good thinking data to provide feedback. You need to ensure that the model not only generates long chains of thought but does so meaningfully, not just to get rewards by talking nonsense. The second insight is that, if the output answer is poor, it is often because the model didn't think deeply enough. This is an interesting discovery from a paper by Tencent. When the model outputs the correct answer, it typically uses fewer tokens. When the answer is wrong, it often uses more tokens. This is not because the incorrect answer is the result of deeper thinking, but because it comes from shallow thinking. The model follows one line of thinking for a few steps, feels hopeless, and switches to another line of thinking. It continues switching, and never finds the right answer, leading to shallow thinking in every direction. This is similar to someone with poor problem-solving ability, who is constantly overthinking. The correct answer, however, is found by thinking deeply along one line. It's like digging a well. If you keep switching places without digging deep, you won't find the water. But if you focus on a few spots and dig deep, you're more likely to find the correct answer with less effort. To encourage deeper thinking, researchers introduced a thought-switching penalty mechanism during the RL phase. Every time the model gives up its current line of thinking and starts a new chain of thought, it loses a point. This significantly increased the success rate of problem solving. Once again, the idea is to seek deeper. The third insight can be summarized by a paper from Berkeley and Google DeepMind titled SFT Memorizes, RL Generalizes. The idea is that supervised fine-tuning is about imitating and memorizing others' problem-solving routines, while reinforcement learning allows you to generalize and think outside the box. Imagine if a student only undergoes SFT but never experiences RL. They will be obedient to the rules, but lack creativity. If a student only goes through RL without SFT, they will figure everything out on their own, but it may take a long time. This paper confirms that RL is crucial for generalization. One example in the paper involves 4 playing cards with numbers. The task is to use the numbers on the cards to form a mathematical equation that equals 24. You can teach the model how to do this kind of task through SFT. But what if you change the rules, such as altering the color of the cards, or redefining the numbers for J, Q, and K? Can the model still solve the problem? Researchers found that only RL allows the model to quickly adapt to new rules. Isn't this how humans learn? Students who only memorize routines, without generalization, lack creative solutions, while students, who frequently come up with clever solutions, don't rely on routines. This suggests that RL is the key to enhancing model capability. And that's exactly what DeepSeek is doing. The surprising thing about DeepSeek's R1 is that it was almost not fine-tuned via SFT, but rather trained directly with RL to give it thinking abilities. Liang Wenfeng's team first used pre-training to create a base model called DeepSeek v3 Base, then directly applied RL to it, which resulted in the emergence of various thinking capabilities. The resulting model is called DeepSeek R1-0. However, this R1-0 has a drawback. Sometimes, during the thinking process, it doesn't speak in a coherent or human-friendly way. It sometimes mixes English and Chinese, has formatting issues, and can mumble incoherently, making it hard for humans to understand its thought process. To solve this issue, DeepSeek added a lightweight SFT phase before RL, called cold start. And this SFT doesn't teach the model how to think, but simply teaches it how to speak human language. I believe DeepSeek's approach of downplaying SFT represents the future direction of large model development. As we've mentioned several times in our channel, Richard S. Sutton's The Bitter Lesson demonstrates that, historically, the thinking patterns taught by humans to AI are often surpassed by the methods AI discovers on its own. This is similar to Go. AlphaGo learned from human player game records, which is equivalent to SFT. AlphaZero, on the other hand, didn't look at any game records and directly learned how to play Go by playing against itself. The result was that AlphaZero outperformed AlphaGo, able to make moves that humans couldn't even understand. It seems that RL is the true key to success. We look forward to the day when large models will produce reasoning patterns and thinking methods that humans do not yet possess or even cannot understand. That will be true ASI, artificial superintelligence. When that time comes, we will learn from it. Currently, what this suggests to me is that human learning can also be divided into pre-training, SFT, and RL methods, although it doesn't usually follow the sequence used in large models. Different people focus on different learning methods, and we might be able to categorize talents into 3 types. The vast majority of people in life are SFT-type talents. They haven't undergone much pre-training, and most of the time, they don't even read books, relying instead on the routines taught in school. They spend most of their time learning by imitating example problems under the guidance of teachers. They are accustomed to following processes and rules, but lack the ability to think critically or adapt. Their learning efficiency is high, and they succeed quickly, but they tend to become specialists, without flexibility. In contrast, generalists are the result of long-term pre-training. These people are well-read, widely knowledgeable, and can talk about a variety of topics. However, without practical experience, they tend to be shallow in their knowledge, often lacking in-depth thinking skills, and may never have truly mastered a specific task. RL-type talents are rare but extremely powerful. These individuals learn by doing, through real-world practice and continuously summarizing experiences. They develop their own methods of problem-solving. Take Mao Zedong as an example. Mao read countless books as a child, and never formally studied military theory, yet when the time came, he immediately led troops in battle, essentially going straight from pre-training to RL. His RL ability was so strong that he never accepted SFT, disregarded rules and protocols, yet often came up with brilliant solutions that made people regard him as a genius. However, after the founding of the country, the situation changed, and he needed to shift from military strategy to economic management. Unfortunately, Mao lacked sufficient pre-training in modern economics, relying blindly on RL, and the people around him dared not give him effective feedback. As a result, he made many major mistakes. In conclusion, pre-training is essential. RL determines the upper limit of one's ability, while SFT is merely a convenient shortcut. That's it for today's content. Thank you for watching, and I'll see you in the next video.
If you feel there is value in this, please like, subscribe to this channel, and leave your thoughts or suggestions in the comments section. Let's grow together and read more good books.